Good afternoon. We're gathered this afternoon, September the 2nd, 2009, at the Monona Terrace Convention Center in Madison, Wisconsin, to conduct an oral history entitled Remembering Verner Edward Suomi, the Father of Satellite Meteorology. I'd like to go through and introduce the distinguished panelists now, and we'll proceed from there. First of all, starting at my right, your left, is Dr. Larry Sromovsky. Larry actually was inspired to become a Suomi cohort based on a physics colloquium he attended early on when he was a physics major here at the university. And Verner Suomi, from then on, seduced, I guess is the word I'll use, him into working for SSEC, the Space Science and Engineering Center, on instrumentation development and data analysis and modeling, primarily covering vertical soundings of the atmosphere and then the planets, a whole range of planets and planetary probes. Larry was a co-I with Verner on the Pioneer Venus net flux radiometer, and a little later we'll get into some of the details of that project. Immediately to his left, second on my right, is Professor Donald Johnson. Professor Johnson is a professor in the Department of Meteorology, and he served as the chair of the Department of Meteorology for a long while, was a Suomi colleague, served as associate director of the Space Science and Engineering Center, and also as director of the Cooperative Institute of Meteorological Satellite Studies, which was founded by Professor Suomi. He's a fellow of the American Meteorological Society and a past president of the AMS, and a little later on we'll get into some details of his interaction with Professor Suomi. Immediately on my right is Dr. Thomas Haig, retired colonel, USAF. Tom was first met Suomi when he was active in directing the development and activation of the world's first operational satellite system, which later became known as the Defense Meteorological Satellite Program. And it was during this time that Professor Suomi consulted with the Air Force and interacted with Tom. When Tom retired in 1968, he joined General Electric for a couple years, and then in a Verner Suomi trip to General Electric in 1970, he convinced Tom to move to SSEC to assume the executive director position, where he was the executive director until 1980, working closely with Dr. Suomi. I'm next. I'm Bob Fox. Followed a trail very similar to Tom Haig, except not quite as illustrious. I too was in the Air Force, ran into Tom Haig there, worked with him as well as Verner Suomi. And when Tom retired from the executive directorship at SSEC in 1979-80, Professor Suomi reached out and tapped me and asked me to come fill those shoes, which I tried to do from 1980 through 2000 as the executive director. Immediately on my left is Professor Charles Stearns. Professor Stearns was a student with the Department of Meteorology while Professor Suomi was a professor there and got his degree here. Then he worked with Verner Suomi on the Vanguard and Explorer satellites. Later on, he joined the faculty of the Department of Meteorology and worked as a colleague of Professor Suomi's. He diverges a little from some of the rest of us in that most of his association was with ground-based meteorological instrumentation, although he did work on the Vanguard and Explorer series. And he is the creator of the Automatic Weather Data Station project beginning in 1980 that populated Antarctica. Immediately to his left is Professor Thomas van der Haar. Dr. van der Haar was a student of Suomi's from the summer of 1963, worked for Verner Suomi as his major professor, and Tom was one of the original members at the creation of the Space Science and Engineering Center. When Professor Suomi formed that, along with Dean Robert Bach of the Graduate School and Professor Charlie Anderson of the department. Tom worked with Verner in many ways, but perhaps his first and biggest thesis publication was the global multi-seasonal measurements of the Earth's radiation budget using data from instruments of Suomi's instigation and joint development cooperation. And last but not least, on the end over there is Professor Dr. Bill Smith. Bill Smith is, again, a Suomi student. Suomi was Bill's primary PhD thesis advisor. And after he got his degree, he went off and worked for the U.S. Weather Bureau in the Meteorological Satellite Laboratory. He worked with Nimbus and aircraft atmospheric sounding instruments. Ostensibly, even then, they had a plan that Bill would return here and work on vertical sounding of the atmosphere, which he eventually did in 1977. He brought 7 federal employees to Madison to work with Professor Suomi on both the development of the Mercatus for display of meteorological data and to do atmospheric sounding work. Bill was the first director of the Cooperative Institute for Meteorological Satellite Studies, and today he's a distinguished professor of atmospheric and planetary sciences at Hampton University in Virginia, and still working on new and innovative satellite remote sensing techniques. All right, that was my shot at introducing you all. Is there any fact anybody would like to add that I missed totally?
The current date is the November 11th, I think.
I don't know, what did I say? I said September. It's November the 2nd, 2009. All right, thank you, Larry, for getting me up to date. When you're old, time flies, you know. All right, we were going to start this off sort of informally and give everybody a chance to warm up maybe with their favorite Suomiism or Suomi story. So you all have at it and tell your favorite Suomi story, and then we'll get into some of the technical details here. Who wants to go first?
Well,
Bill?
One personal story I have. Actually, Professor Suomi was not my major advisor. I mean, not my major professor. He was my primary PhD thesis advisor because of the area that Professor Lyle Horn was actually my major professor. But Suomi was very instrumental in a lot of the work that I've done during my professional career. The story I remember most is actually on the Sunday, the day before my PhD defense. I had given Professor Suomi my thesis many weeks earlier, but never heard anything from him, so I thought I'd better call him and make sure he knew about my defense being the next day. And when I talked to him, it seemed like he didn't realize that I had my defense the next day, but he never let on that that was the case. Instead, he said, Bill, he says, come on out to the house. Give me 3 hours and then come on out to the house and we'll talk about your thesis, which I did, and it was a very memorable experience. He had obviously read my thesis well because we had a very good discussion of it at his home. And then near the end of our discussion, Paula, his wife, invited me to stay for dinner, which I graciously accepted to do that. And I got to know Suomi's wife for the very first time then. And I remember thinking during the dinner, that old adage that behind every great man there's a great woman, because Paula was certainly that. Well, the story doesn't end there. The next day, my oral defense took place, and it went pretty well, except for one question that Professor Suomi asked me, and he hadn't asked me that the day before when I was out to his house. And he asked the question, he says, why can you see further with infrared remote sensing looking down from a satellite than looking up from the ground? And I didn't really know the answer to that, but Professor Suomi went on to explain that infrared remote sensing is like looking through a series of glass panes, each atmospheric level being a different glass pane. And he says the planes get dirtier as you go from top down due to a phenomena called the pressure broadening of absorption lines. This is kind of technical, but he says when you're looking up from the ground, you're looking through the dirtiest panes first, so you can't see very far. Whereas when you're looking down from a satellite, you're looking through the cleanest ones first, and therefore you can see further. And I remember thinking how dramatic that was at the time, but I didn't appreciate how that simple question and the answer to that would impact my professional career from then until this very day. So that's my story.
Thank you, Bill. Anybody else?
Well, I can have a story that's sort of secondhand, so maybe I shouldn't even talk about it since I wasn't actually there. But
We gossip. Go ahead, Larry.
I'll try it anyway. This occurred during the Pioneer Venus program. This program resulted in probes entering the atmosphere of Venus. That happened in 1978. And during a meeting to discuss the Pioneer Venus probe targeting, Suomi was very anxious to get one of the probes as far towards the pole of Venus as possible. The problem was the science team was very reluctant to do that because the communications becomes difficult when you do that. So there was a risk that you'd lose the Doppler radar tracking and also the data transmissions. But Suomi nevertheless insisted on making a risky decision. During a break in the meeting, he had Sanjay LeMay, who was at the meeting with him, go down to the machine room and put as much money as he had into the machines and get all these packages of almonds. I don't know. I've never seen a machine that has almonds in it, but apparently that happened out there. Anyway, Suomi then labeled each package of almonds bravery pills. And then when he got back to the meeting, he handed them out to all the people in the science panel and saying, swallow your bravery pills and pick the high latitude target. And he used that swallow your bravery pills concept many times since then.
Anybody else?
Well, I'll tell you, when I first came to Madison to join SACC, I moved into a home out in Monona that needed some repair work. And one of the repair jobs involved a lot of plumbing. And Suomi, I told him about it, and he said, well, I got a pipe wrench, might help you. So he came out and he brought a pipe wrench that was about that long. It was the biggest pipe wrench I'd ever seen. And it was exactly what we needed because the pipe we had to undo was a huge thing and it had rusted shut, of course, and everything. So we struggled with that all afternoon. Got it open and did all the plumbing. I won't go into that anymore. But then we were exhausted, of course, and sat down to have a little something over a bottle and chalk. And we got talking about our earlier lives when we were younger, like kids and this sort of thing. And Vern told me about his early life on a farm up in Minnesota and how his big brother Frank had cared for him. Frank was 2 or 3 years older, I guess. And as Suomi described him, he was much bigger, stronger, and smarter. And Suomi idolized him. And he went on, it's quite a long time, and then said that as he grew older and it came time to go to college, his brother decided that Vern was the one that should go to college and that Frank would stay back and work the farm and supply the money that kept Vern in college. And that's how it worked out. And Vern went on and, of course, had a very distinguished college career, and then just about the time he graduated, Frank died. And Vern said, "My one deepest regret in my life is that I could never repay Frank." And so I think he felt very strongly about this. I think it was really one of the formative moments in Vern's life. And that for the rest of his life, I think he actually worked extra hard to try to justify his brother Frank's sacrifice in sending Vern to college. That always stuck with me. It kind of characterizes the man.
I've got a personal one too. Bill mentioned his wife, Vern's wife, Paula, and sometime in the late '60s, we were on a trip together, and he would relax after a busy day, and like to talk about personal things. And I had a few young children, and Vern's children at that time were certainly teenagers or maybe even a little beyond. And he started giving me some advice as a parent about children, but then he expanded that to include young scientists and students and a few others. And he said, well, you know, it's a little bit like a man with a bow and arrow. He said, with the children or these young scientists, you have to point that arrow in a certain direction, pull back, give it as much force as you can, and then you have to let it go. And what happens after that is really out of your control. And that's some good advice, I think, for all of those groups of people that I've tried to follow over the years.
Well, I've got one that's a bit different. We were invited out to Champ Tanner's house for pizzas. And in the process, one oven was not working. So we get the screwdriver and the other things and the pliers and start taking the damn oven apart to see what was wrong with it. And a little while later, here came the guy that sold the ovens to Champ Tanner, and he pushed a little button and away it went. But we had the damn thing all apart and had to put it back together.
Let me follow up on the two Toms here with a story. When I was down at Scott Air Force Base when Don Johnson called me and asked me to come up for an interview for the executive director position. So I drove up on the appointed day and discovered that Verner Suomi was in University Hospital on the eve of his coronary bypass surgery. And for my interview, I was given directions to the University Hospital on University Avenue. And I went over and sat in the hospital room with him in his cute little hospital nightie, tilted up on his bed, and had my interview for this position as executive director in the hospital room the night before his bypass surgery. That's always been to me a measure of his dedication to the job and getting things done. It's also awesome to contemplate going to your job interview in a hospital with somebody who's about to have coronary bypass surgery. Following up on that, though, Bill's comment about behind every successful man is a great woman. He went on to have a couple more heart surgeries after that, and at every heart surgery, Paula would start baking about a week beforehand, and by the time the day of surgery came, she would call me up and ask me if I could send somebody to the house because the freezer was totally full of cookies, and could we come and haul away 15, 20 pounds of cookies so she had more room to bake more. And she baked and baked and baked all the time he was in the hospital. And it was really a time of mixed emotions because we ate absolutely great while he was in the hospital recovering from surgery. Don?
Well, I'll follow up on Tom here. To some extent, Suomi had a unique value of life, and it showed that from his relationship to his brother and getting the chance to go off to college. Became a teacher in high school and always had this unique capability of explaining science to the man on the street. Then he went off to the University of Chicago in about 43, stayed there to 48, and he actually headed their laboratory and was involved in the development of several unique instrumentations to measure water vapor, actually sonic anemometer, turbulence, even prior to this work on radiation. But then you go on to how he actually got into, and of course he had some of these discussions on radiation, field measurements, cornfields and things like that. But there was a story told by scientist from Ohio who was here working, had been in Washington office with Harry Wexler, who was chief scientist of the Weather Bureau at that time. And Harry Wexler told this man to go back and see if Suomi had any ideas for a satellite experiment. Next morning, Suomi's on a plane to Washington, proposed as Explorer 7. That's not the only time this happened, because he was always prepared to take advantage when certain events happened here, there, or everywhere. Another one that happened, we'd already get on and well towards the development of Mercatus and satellites, of these people here in particular. There was a series of tornadoes in Kansas that wiped out a town or two, and congressmen from Kansas call up NASA and want to know what they're doing, because they had made all these promises about weather. And what did they do? They turned around and called Suomi, can you help us in explaining to Congress what we're doing? So they actually, 3 of them came out here, and we had congressional hearings here in the Space Science and Engineering Center. That led to the exportation of Mercatus, this system that showed imagery, meteorological information, to the Kansas City Severe Storms Lab, to Oklahoma, to Washington, and all over the world eventually. So I don't know how many was sent as far as these systems, but somebody said 60 here earlier in the day. Tom here would know far more about that than me.
There was upwards of 60 of these Mercatus units in various models. As technology progressed, you could make them neater, smaller, and more efficient. And the boys up on the 4th floor were just so eager to try a new model every time. So we built a lot of those things and almost gave them away at cost to just about every government agency throughout the world.
Well,
And it revolutionized meteorological analysis and presentation worldwide.
yeah, in that sense, they went to China. They actually had a system that observed hurricane, typhoons, I should say, in the Bay of Bengal to warn Bangladesh and places like that of oncoming storms. And essentially, Suomi was very proud of the fact that before that happened, 200,000 or 300,000 people could lose their life, and now the loss of life was down to 5,000 and things like that. So,
All righty, I think I'm going to first call on Chuck Stearns here. I think it's sort of fitting this oral history is being taken in conjunction with the 50th anniversary celebration of satellites and meteorology. And it was 50 years ago this year, as I understand it, that Explorer 7 carried Suomi's bolometer into space and returned it. And since you were an integral member of that team, along with Verner, with the Explorer 7, and because we have an artifact under our chair and I don't want to step on it, so I'm going to start with it so I get it out of the way.
All right.
I'll turn it over to you and let you tell us a little about Explorer 7.
Well, Suomi wrote a proposal to National Science Foundation, which I never saw, proposing to do something on the Vanguard rocket, which was financed by the NSF for this one of the first uses of rockets to carry something into space. And so we were designing the system for that particular rocket. And at any rate, we put the thing together, and in the process of doing that, we had a lot of stuff to learn. One of the first things was that we had to use transistors instead of vacuum tubes because there's not much power. And we had the power in the little package that was going to go on the satellite was really from batteries, little I guess they were mercury batteries. I don't know which was in them, but at any rate, a pile of batteries. It was going to run for a month or two. That's all. And they had a sphere that was about this big around, and inside of that was this little situation of tube in there. And on the outside of the tube, there were transistors used to make up data words. And the data word had about 10 to the 28 places, 24 places for it. And the sensors, well, this was similar to it, but we had little round balls that happened to be painted black and white. Some of them were black and some of them were white. And at any rate, it was just old stove paint. Because I found this, I was trying to find out what should I use for a paint, and I didn't. I figured that stove paint would be the stuff that would last the longest. So that's what I bought. I don't even know where I bought it now. At any rate, and the second thing was that the system was going to have to withstand severe vibrations. Now, I took a look into this Vanguard satellite, and I could see these different wires hanging down in that satellite, and I decided right then and there, this isn't going anyplace. And so I packed up and got in the car and went home. I didn't even want to watch the launch at all, because, well, at any rate. And the third thing that we had to do was have a short-term memory for the data. And the short-term memory for the data happened to be a little tape recorder. And you could wind it up on a spring-driven reel and then let her go to play it back. And it worked. And well, I don't know, it was maybe had a yard of tape or whatever it was. It was a metal tape. And that was our short-term data, and it would store, a little more than the data that's taken in half of a orbit of the satellite. And at any rate, the data had to be transmitted to land-based stations, and there weren't very many land-based stations to collect data from satellites at that time. Like now, they're all over the place. Back then, they had to set them up. And another thing that would appear to you, if you did a little calculation, what in the world are we going to store this data on? The data storage systems were magnetic tape, you know. Well, it turns out if it lasted too long, we'd fill up all the world's tape for computers, something like that. And then the last thing that we had as a problem that we didn't know what to do anything about was that we didn't know what was going to happen to something you put into space. How will the surfaces be changed? Because if we put something up there that depends on the surface and it changes with time, it's going to give us a different number, and we had no idea what that was going to be. At any rate, we had to overcome these things, plus we were, as a group, were doing something we had never done before. And I had the job of designing a little gadget that had some gears in it, and it would move 5/1000th of an inch every pulse, which is about once every second, and it would chop along and put the stuff on the data and wind it up on this spool, so then we could pull a pin and raise it and have it play back to go down to the ground. And you, Tom, collected that data,
At
I
Fred
guess.
House, I remember. Fred
And,
House. Mhm. We did.
Yeah, and all of this had to be modified from the Vanguard system to the Explorer 7 system, which was entirely different. Now the Explorer 7 system had the advantage that it had some solar panels on it, and this thing could run our station for years, at least a couple years, something of that order, and make it really worthwhile. But we had to make a different type of sensor. Now this one is decayed, didn't go up or not, but it was this little ball here that was either painted black or white, but it was this, in this case, this was put gold on there. And so we have a measure of the temperature in there with a thermistor, and that temperature then is measured by the 1,000 and what is it, 24? 24. I can't do my mathematics. 1,024 counter in there, and at any rate, I don't think it's really a very good sensor, frankly. This surface here was a beautiful front surface mirror. It looks terrible now, but when we put it up, when we put them in space, this was a beautiful mirror, perfect mirror. And I got that for nothing from some place. I don't know where it was now. But at any rate, I probably made promises to them. But I did have a little problem with this from my point of view, because, of course, the Army then, as soon as I sent these things down to be installed, they rattled them a little bit, and of course they came apart.
No.
And I had failed to properly clean the mirrors and stuff before I glued them down with some epoxy glue. So they said they were going to put a chunk of concrete in there and call it the University of Wisconsin experiment if I didn't get on the ball. And I did. I did get on the ball and take care of it. But my fun item there was the purchase of these transistors for Suomi wanted, and he gave me the job. Suomi was in the engineering building with Parent doing the stuff with the thermistors or thermocouples, and at any rate, and he didn't like to get over to the meteorology department because he'd find that he had to do something over there. And he got me to teach his classes so he wouldn't have to come there, I think. So I had to take care of his 2 classes, well, 1 for each semester. And then Suomi and Bryson found out about it and didn't like it. He was the chair at the time. But I was fully qualified as far as I was concerned to teach those classes. But I'm a graduate student now, and I'm not paid very much. But at any rate, I had to work 12 hours a day just the same. But at any rate, on buying these transistors, I just called up good old, what was it, Texas Instruments, and said, I need whatever it was, 40 or 50 of these things at something like $35 a piece. And so they said, sure, don't worry about it. And about 3 or 4 days later, we got our transistors. And Suomi had what he needed to get going. But a few days later, the bill came into the purchasing department, and following the bill to the purchasing department came the purchasing order to the purchasing in the University of Wisconsin. And this is about the biggest no-no you can go do. Nobody is ever to order anything without letting the university go out on a bid for it. And if they'd have gone out of bid, who knows how many years it would have been before we got those transistors. And we had to have them tomorrow, sort of thing. And so the purchasing got to chew me out very nicely for it. And I accepted that, and Suomi didn't know anything about it. So I thought that was a pretty good trick, because I got it done. I got the things bought. And at any rate, as I said, the Vanguard system went in the ocean, and then we had to design a newer system for trying to measure the radiation in the long wave and the short wave and so forth. And we came up with this thing, which probably wasn't too good, but it was, I don't know how Tom processed this, but the magic here was done by Tom.
And Fred House, I have to say.
And
again,
Fred House,
He really
yeah.
taught me a lot.
I know
And, Suomi came up with the idea, if I can interject, to make these very simple sensors work. He claimed that he could do it with a piece of bubble gum. Remember that? But
Wow.
the idea was that when the satellite went through the Earth's, into and out of the Earth's shadow, across the terminator,
Yeah.
you got a big signal from the sun or you lost the signal.
Yeah.
And with the aid of that concept, we were able to do what was the first in-flight calibration of the radiometers.
Yeah.
And that was the key. And I think Suomi, before he left us, did talk on some oral history tapes about that concept a little bit.
Yeah.
So-
Well, I knew that was going to be an important thing.
That was big.
But it was about that time, before it went into orbit, that I quit and we started working with Letow,
Yeah.
which was more up my field than my interest.
I guess I would remind you, Chuck, that good is time dependent. And what may not look so good now was probably absolutely great back in those days.
We
Right, yeah.
had no choice, absolutely no choice.
And since Tom made a thesis out of it, I guess he thought it was probably better than good.
Yeah, it
So-
was great. And in fact, we're celebrating in this 50th program on the 50th anniversary of the legacy of those sensors. Chuck, you might say the early experiment engineer or something,
Yeah.
although Vern might say he was. But you got the work done, and it was a grand success. And actually, the Russians even received some of the data. They had a readout station.
Well,
and-
Suomi said to them said he was going to keep all the data for himself.
They were broadcast, to stations. The Russians had the ability, and this was out of scientific cooperation
Yeah.
in the International Geophysical Year, and they actually published a paper
Oh, they
using
did?
some of the data. Yes.
I was a little surprised, Chuck, to hear you say that you taught Suomi's classes for 2 semesters, because I thought he had a great love for teaching
They did.
and love of his students.
Great love for my teaching.
He had a greater had a greater love for science and research. Huh?
No, you
So
got-
I thought I would.
Suomi was charging as fast as he could to get stuff to work at that time, because we had to do everything for this Vanguard satellite. And we only had about a year and a half to do it. And it was hard to do it. You had to work all the time. But he was charging. He really was. He was trying to get it done.
I thought I'd follow up on the teaching thing with Tom, since Verner was your major professor, and you had a lot of insight into him as a teacher and his students and his love of teaching. And in fact, I even heard a rumor that he, while he was chief scientist of the Weather Service, that he quit and came back early because he wanted to be with his students. I always thought that was because he probably hated the administrative part of the job, but you can comment on that.
Well, I will. Vern said this many times. The purpose of the university is to educate students. He said it so often it was like a mantra, and I'm sure others have heard him say that too. But at the same time, he was certainly excited about following his new ideas and his new innovations, and so he always had to balance that. I would say he was a dedicated teacher, but he taught a lot outside the classroom. And even the graduate classes that we attended at that time, people like Steve Cox, Bob Nolenberg, Bill was there. I don't know if Don ever took a class, but Vern's graduate classes were more like idea shops, where he'd come in, he'd tell us a month before that we were going to do this, and then he'd go on a trip and get some new ideas and come in. It'd be a totally different agenda. We were working on projects like measuring the energy from the sun with a balloon launched from an aircraft carrier in the Atlantic and how we would do that. Putting an air horn on a balloon to get the temperature profile with acoustic propagation information, you know. Vern had a lot of ideas, but I would say he was a dedicated teacher, and I think another example of that was his interest in the students and the faculty in other departments here at UW. He worked a lot with electrical engineering, not just the faculty, but the students. He worked with the physics group, the astronomy group.
Champ Tanner and Soils.
In soils. He came here originally, worked with the soils department. So he was a very collegiate, maybe an eclectic person. He didn't have boundaries. He saw no boundaries in education and things of that kind. Now, about going to Washington, I was here when he left us for a year. I think he was on sabbatical to be the chief scientist at the U.S. Weather Bureau. And I think he came back to be with his students, but and maybe because of the bureaucracy out there in whatever it was, K Street or wherever he had a little office. But at that time, he was beginning to get that concept of the spin scan cloud camera. And I talked to other people who were out in Washington at that time with him. This would have been 65 roughly. And they said, well, let's see. I was out there and Vern had me holding a globe and he'd stand back a certain distance from the globe and this guy had to spin the globe. So Vern was already getting the idea for the spin scan cloud camera, which was one of his great new technologies after the Explorer and all that. So maybe he came back to pursue that idea and to be with his students. I don't know. What do you think, Bill?
Any other comments on Suomi and his students and teaching?
Well, he used to teach by posing Gedanken experiments where you had to think. I remember one of them, I wasn't his student, of course, but he tried this on me anyway. He said, suppose you're in an elevator with a floor that is unwettable. It's slick and the water won't wet. And there's a droplet of water on the floor of the elevator. And the elevator suddenly falls in free fall. What happens to the droplet of water? Well, you're supposed to think about this and say, surface tension on the droplet will cause it to close up and it'll probably go into an oscillation like this, and it will immediately leap off the floor, and it will float. And at this point, Suomi would say, all right, now calculate how fast it's leaving the floor. And at that point, the student and I gave up. Because, I said, can you calculate that? No, but it's a good question.
I think everyone in the world who ever knew him was a student of Suomi's because he posed thought experiments all the time to get reactions.
Right.
As long as you're talking there, Tom, you worked with Suomi while you were in the Air Force on development of the first operational meteorological satellite program. Yeah. Could you give us a little insight on how you interacted with Suomi and what type of work he did and how it went?
Well, the program was supposed to be a very short interim one-year program to fill in for the National Reconnaissance Office. They had finally succeeded in getting a reconnaissance satellite to return some pictures and discovered that there were 85 or more, 86% clouds images, very little of the ground. So they decided, holy smokes, we need a meteorological satellite up there to tell us where the clouds are so we can take pictures where they aren't. And so they started my little program. We had just had a successful launch after 9 months from start to first launch. It returned pictures. It was based on a little Vidicon camera up there, just taking television pictures of the Earth. And these were the first cloud images on an intentional basis. A couple of years before that, NASA had launched a first Tyros with a Vidicon in it, which proved that a Vidicon would work in space. What RCA did then was to propose a better satellite which would take a whole strip of pictures properly oriented, and you could tell where the pictures were taken, and that was my little program. Anyway, Suomi, after Explorer 7, didn't have anything up there in orbit to put an instrument on, so he asked Dave Johnson, when are you going to have something up I can put an instrument on? Dave says, well, NASA is messing around with Nimbus, and it'll be several years before they get anything up. But Tom Haig has got a little program out there on the West Coast. Go out and see him. So Dave called me, said, I'm sending Verner Suomi out. He's a professor, University of Wisconsin. Listen to what he has to say, and if you can accommodate him, great. So he came out. Vern says, all I want to do is to put 2 little sensors. All they are is 1 inch in diameter aluminum foil, one pointed white, one painted black, on other sides of your satellite. As the satellite goes around, they will see space and then the Earth. And we will take the difference in the measurements from the 2 little thermistors that are glued to the back of these little pieces of aluminum, record it on a recorder, and dump it on the ground. All you have to do is to give me one command to tell my little recorder when to unwind and dump the data. So we said, well, okay, we can accommodate that. We worked for 3 or 4 hours, had it all designed, set it up, and it flew on our 5th satellite, actually our 2nd successful launch. And the data that came down not only gave good albedo information, but the people in the Global Weather Center also got a copy of the data, and they decided, holy smokes, we can learn about nighttime cloud cover from this, because the sensor was telling what the temperature was really that they were seeing, and the temperature will tell them where the clouds are. And they very quickly developed the software to do that. Well, I got a call a couple of weeks after that saying, keep a Suomi sensor on all your satellites from now on. Their data that we don't care about his Earth budget measurements. We want it for nighttime cloud cover information. And so it became then a reconnaissance satellite sensor, which is not what was intended at all, but it became very important. And there was later on, in one of our later models, this is a great big beastie thing, our satellites got bigger, heavier. Shows the diameter of the satellite. It was not a very big one. But these things around the sides now are all Suomi's sensors. The first one had 2 little flat plate sensors. This one obviously has a set of, I think there are 8 or more sets. And they are now not flat plate, but conical, which gives them more resolution, and they're pointed in different directions. So they're getting higher resolution, infrared, cloud cover imaging at night from this thing. And so it was serving the reconnaissance satellite program extremely well. And it went on until they finally went to an entirely different kind of a satellite that had an infrared scanning device which gave whole images in infrared, and you didn't need to do it this way anymore. But this was a very successful and very useful program to the national reconnaissance effort, which is not what Suomi intended at all, but he did it.
You were using on the first one, Suomi was using the same satellite equipment that he put on the Explorer 7.
Well, they were flat plates, Chuck.
I know they were flat
They're the
plates.
same concept that he'd done
Yeah,
really
same one.
all the way back to Explorer 7.
It may have been the same recorder.
I think it was.
Yeah.
Is a little 5-ounce thing. I guess Parent had
Yeah,
a
it's
great
about this
deal
big around.
to do with building it. And it used the spring from a Big Ben alarm clock as its source and little rotary solenoid, and it advanced that little magnetic tape
Right.
or wire each time, printed out an 8-bit word, and then dumped that by just pulling the little latch on it, and
right.
it came down. And Tom can tell you all about how the difficulty of analyzing that data, because it came down at a very highly variable rate. When you listened to it, it would go as that spring unwound, you know.
Yeah.
And he had he had to calm that down to make it an even rate of data. Is digital word, of course, but the computer can't take it at that uneven rate. You had to calm it down, make it all at one rate. Then you could dump it into a computer and read it. Tell us about that, Tom.
Well, yes, Chuck talked about even that magnitude of data in those days was taxing the systems. Fortunately, the Air Force had this was a near polar orbiting satellite, so they had readout stations in the polar regions, perhaps in Greenland or somewhere like that. And then, so they could capture the data better, but then on the ground we had to stretch it, reprocess it, check those little hack marks. And I think it's a great example of Vern's idea to take an idea and to find an opportunity to fly it. And here he was supporting